Hello, this is Dr. Daystorms, and this is the second PowerPoint presentation or lecture, if you want to think of it that way, for Chapter 1. And here we're going to start talking about the properties and changes of matter, and different types of properties and changes that matter can undergo. Okay? First off, we have physical versus chemical properties. So what exactly makes a physical property, and a chemical property, a chemical property? A physical property can be observed without changing a substance into something else. Okay? So, if we want to think of it that way, what are some of the physical properties that you can have? Well, we can have boiling point. You can have the density, the mass. You can take something's mass, see how much it weighs, and you're not changing it to something else. You can take the volume, see how much space it takes up, and it's not changing it. Whereas a chemical property is going to be something that you can only observe when the substance is changed into something else. So if we look here at this example, where we've got the flames, we have a piece of wood, and we have lit it on fire. Is this a physical property or a chemical property? This is actually a chemical property because it's changing the carbon of the wood, reacting with oxygen in order to form carbon dioxide and water. Okay, so the flammability, corrosiveness, you react it with acids, bases, oxidizers, things like that. Those are chemical properties and not a physical property of the matter. Another way to look at things, look at the properties of matter, is intensive versus extensive properties. So we've done chemical properties versus physical properties. Now we have intensive and extensive. So chemical and physical properties had to deal with whether or not it changed the compound that you're observing. Intensive and extensive properties have to do with the amount of the substance that there is. So for example, an intensive property is independent of the amount of the substance that is present. So if you imagine you've got a cup of water and you have a gallon of water. Which one, if either, is going to have more or have a higher boiling point? If it's pure water, they're going to have the same boiling point regardless of the amount. That's an example of an intensive property. Boiling point, melting point, density, color, things like that. So what's an example of an extensive property? An extensive property does depend upon the amount of the substance that's present. So an extensive property could be volume, mass. Just think of it. The amount of space that something takes up matters by how much of that matter you have, how much of that substance that you have present. The energy of a system, if you have more matter there, it's going to be higher in energy. If we want to look further, let's look at physical versus chemical changes of matter now. Here we have a physical change. A physical change is one in which the substance, the composition of the substance does not change as it goes from one physical state to another. Whereas a chemical change is going to be one where the substance is converted into a new substance. So if we look over here at the water that is melting from the solid state to the liquid state, are we really changing the composition? No. So melting point, the melting point, boiling point, those are changes of state. That doesn't change the composition of the substance, or temperature, the volume. Those changes in mass, those are not changing the actual matter, okay? So that's why you can take ice, which is just frozen water, you can melt it, and now you have liquid water. Whereas a chemical change results in a new substance. So if we go back to the idea of burning wood, we're changing that from a hydrocarbon to carbon dioxide in water. Decomposition, oxidation, reduction reactions. These are all chemical changes. So to reiterate here, we're stating that in the course of a chemical reaction, you're going to have reactants combining together to form new substances, called products. So we have reactants becoming products. In biochemistry, we like to use the word substrates instead of reactants, but it means the same thing. Whereas a compound, to review from the last class, the compound is something that you can break it down into more elemental particles. So like water can be broken apart via hydrolysis into oxygen and hydrogen. So I just found this video, and I thought that this was a really cool video on an actual experiment doing electrolysis of water. It's only a couple minutes long.
In that small plastic container are two metal push pins, and they're inserted a distance that's between the positive and negative lead of the 9-volt battery. So you just insert them in there and make sure that they're that distance apart, and that should be fine. In the container is going to be some water that has baking soda mixed into it. The baking soda in the water allows electricity to flow between the two metal tips of the push pins. And so now you set them on the leads, and the electricity can flow between the two push pins now. And so electricity is flowing through the water, and so that's enough energy to break apart the water, make it undergo a chemical reaction, so that the H2O gets broken apart into H2 and O2. It's going to be hydrogen gas and oxygen gas. And both gases are going to flow up through the test tubes, and one of the gases is going to be in one test tube and the other one's going to be in the other one. How do you know which one's which? Well, if you take a look at the amount of gas in each test tube, it's going to be twice as much hydrogen gas as oxygen gas. So you can see in the right test tube, you have twice as much hydrogen gas as oxygen gas. This is how experimenters first learned that the ratio of hydrogen atoms to oxygen atoms in water is 2 to 1. It's 2 to 1 ratio, thus H2O.
So hopefully this helps answer questions or starts a discussion on the different types of the properties of matter, whether it's intensive versus extensive, physical versus chemical, so on and so forth. I'll see you in class.